For example 4, determine the number of terms in this finite sequence. So it skips over a bunch of them and then says this is what the final number is going to be, or my final term. So we know that term 1 is going to equal negative 52. We can solve the common difference by saying it's going to be negative 56 minus negative 52, or negative 4. If I know the value of the last term, I'm just trying to solve its term number. So I'm going to say that negative 148 is going to equal negative 52 plus n minus 1 times negative 4. And I'm going to solve it just like we did the last example. I'm going to subtract negative 52 or add 52 to both sides and say that negative 96 is equal to n minus 1 times negative 4. Divide both sides by negative 4, and I get 24 is equal to n minus 1. And then I'm going to add 1 to both sides. 25 is equal to n. There are 25 terms. For example 5. Now it gives me the value of 2 of the terms, the value of term 3 and the value of term 8, and it wants us to solve term 1 and term 34. Well, obviously I don't know term 1 because that's something I'm going to be solving. But I know term 3 and term 8, which means I actually have enough information to solve for what my difference is. If I think of it like this, if I have term 3, then term 4, 5, 6, 7, and 8, then I've changed 1, 2, 3, 4, 5 times. I can put that into my formula and say, well, my difference is going to equal 34 minus 4 divided by how many changes did it have? Well, it had 8 minus 3 changes, or as we already counted out, 5 changes. So this is actually a change of 30 over 5 changes. It should change by 6 every single time. I can use this difference as well as the value of one of them. I'm going to use the value of term 3 to solve what term 1 is by just replacing information that I know. I'm going to say that, well, the value of term 3 is going to be 4 is equal to term 1 plus, I know it's the third term, minus 1 times the common difference of 6. Or 4 is going to equal term 1 plus 12, subtract 12 from both sides, and negative 8 is equal to my first term. And there's the first part. For the second part, where it wants what is the value of term 34 is going to equal term 1, which we now know is negative 8, plus 34 minus 1 times 6. Term 34 is going to equal positive 190. If I'm doing the same thing with variables, the sequence below is arithmetic, find the missing terms. Well, it tells us it's arithmetic, which means that it's changing by constant amounts every single time. We know that our formula to solve the distance is going to be a term minus the term that came before it. So let's take the second term, x plus 3, minus the term that came before it, 4x minus 2y. This would be the same as x plus 3y, and then if I apply the negative, negative 4x plus 2y. Or negative 3x plus 5y. This means that, theoretically, x should be decreasing by 3 every single time, which it is, and y should be increasing by 5 every single time, which it is. So I'm just going to keep that pattern going. I'm going to say that if I continue to decrease x by 3, I'm going to get negative 5x, negative 8x, and negative 11x. If I continue to increase y by 5, I get plus 13y, plus 18y, and plus 23y. For the last example, it's putting this into application. An amphitheater has 25 seats in the second row, which means that term 2 is going to equal 25. 65 seats in the seventh row, term 7 is equal to 65. And the last row has 209 seats. We can call that Tn or Tf for the final term. Doesn't really matter. The number of seats in the rows produces an arithmetic sequence. How many rows of seats are there in the amphitheater? So the first thing I'm going to do is, like with example 5, because this is very similar to example 5, I'm going to solve for what that common difference is. The difference is equal to 65 minus 25 over, this is the seventh term, and this is the second term, which is going to give me 40 over 5 changes, or it's changing by 8 every single time. I'm going to use the value of one of these terms. I'm going to use term 2 to solve for what term 1 is. And I'm going to say that the value of term 2 is 25 is equal to term 1 plus 2 minus 1 times 8. Or 25 is equal to term 1 plus 8, which means that 17 is going to equal term 1. If I know term 1 and I know how many seats are in the last row, I can solve for the number of rows. 209 is equal to 17 plus n minus 1 times 8. 192, when I subtract 17, is going to equal n minus 1 times 8. Divide by 8, and 24 is equal to n minus 1, and add 1, and 25 is equal to n. There are 25 rows in the amphitheater.